Welcome to Chetan classes. Today we are going to learn new chapter, partial fractions. First we will see the definition. Definition: P of x is equal to a0 plus a1x plus a2x square plus dash 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 up to an x raised to n, where n belongs to whole number. The degree of the polynomial is the highest degree of the term involved in the polynomial. For example, degree of 3x square plus 2x plus 1 is, यहाँ पे हाईएस्ट पावर कौन सी है? x स्क्वायर, मीन्स 2 पावर x की पावर हाईएस्ट है. तो यहाँ पे डिग्री ऑफ दिस पॉलिनोमियल इज 2. नेक्स्ट एग्जांपल, डिग्री ऑफ x plus 1 into x plus 2. Now solve this polynomial. So degree of, here multiply, so x square plus 2x plus x, that is 3x, and 1 into 2, that is 2. So here highest term is x square. So what is the power of x? 2. So again degree of this polynomial is 2. Now this is first example, this is second. Now third example, degree of x square plus 1 into x minus 1. Solve this. So here degree of x cube minus x square plus x minus 1. So x cube. So here degree is 2. An expression of the form ax plus b, where a is not equal to 0 and a comma b belongs to real number, is called a linear expression or linear factor. Its degree is 1. तो linear expression और linear factor means जो भी expression की degree 1 होती है, that expression we call as linear expression or linear factor. Next, an expression of the form ax square plus bx plus c, where a is not equal to 0 and a, b, c belongs to real number, is called quadratic expression. Quadratic expression. For example, 2x square plus x minus 1. So here highest power of x is 2, so it is quadratic expression, and if we find the factor of this equation, then we get 2x minus 1 into x plus 1 are called reducible quadratic expression. Next, an algebraic fraction or rational function is an expression of the form px upon qx, where p of x and q of x are polynomials in x. For example, x upon x plus 1, x minus 2, then 2x plus 1 upon 2x square plus x minus 1, etc. are all algebraic rational functions. It can often be rewritten as the sum of simple fractions, which are called partial fractions. So we have two partial fractions, that is for proper and improper fractions. See the definition. When the degree of the polynomial in the numerator is strictly less than the degree of the polynomial in denominator, the fraction is called proper fraction. For example, x upon x square plus 2x plus 3. So here degree of numerator is equal to 1 and here degree of denominator is 2. So 1 is less than 2. So this is the example of proper fraction. Now, when the degree of the polynomial in the numerator is equal to or greater than that of the denominator, the fraction is called improper fraction. For example, x square plus 1 upon x square minus 1. Here degree of numerator is equal to 2 and degree of denominator is also 2. So this numerator and denominator degree is equal. So this is called improper fraction. Next, partial fraction of proper fraction. In the proper fraction, the algebraic fraction P of x upon Q of x, where Q of x is not equal to 0 and degree of P of x is less than degree of Q of x. So when we solve this proper fraction, there are some rules to find the solutions. So first rule, rule 1, when denominator has distinct linear factors. For example, 3x upon x plus 1 into x minus 2 are in the form a upon first factor, that is x plus 1 plus b upon x minus 2. Here we have to find partial fractions of. So here I add here partial fraction of 3x upon x plus 1 into x minus 2. So here in denominator x plus 1 and x minus 2 are distinct linear factors. So steps are, first write the question in the form of a upon first factor plus b upon second factor. Then to find a and b, and then we substitute values of x based on the root of each linear factor. That x plus 1 is equal to 0. So we get here x is equal to minus 1 and x minus 2 is equal to 0. So we get x is equal to 2. Okay. Example based on rule 1. First example, resolve into partial fraction one upon x square minus 1. So first find the factors of x square minus 1. So here x square minus 1 means x square minus 1 square. Here apply the formula a square minus b square is equal to a plus b, a minus b. So here x plus 1 into x minus 1. Here we apply the formula a square minus b square is equal to a plus b into a minus b. Okay. So here consider this partial fraction 1 upon x square minus 1. We write as a upon first factor, that is x plus 1 plus b upon x minus 1, because here we are getting distinct factors. Now cross multiply. So here a into x minus 1 plus b into x plus 1 upon x plus 1 into x minus 1. Here in our left hand side 1 upon x square minus 1. Now in RHS x plus 1 into x minus 1 is same as x square minus 1. So in both the sides our denominator is same. So equate the numerator. Therefore, we get 1 is equal to a into x minus 1 plus b into x plus 1. Consider this equation as star. Here we are getting distinct factors. So put x is equal to 1 in equation star. We get 1 is equal to a into 1 minus 1 plus b into 1 plus 1. Therefore, 1 is equal to here a into 0 plus b into 2. Therefore, 1 is equal to 2b. So, b is equal to 1 by 2. Now, put x is equal to minus 1 in equation star. Here, note that how we find the value of x is equal to 1 or x is equal to minus 1. So, one trick is there. Our factor is x plus 1 or x minus 1. So, here x minus 1 equate with 0. So, we get x is equal to 1. So, this put x is equal to 1 over here. And next factor, that is x plus 1 is equal to 0. So, we get x is equal to minus 1. So, put x is equal to minus 1 in equation number star. Therefore, 1 into 1 is equal to a into minus 1 minus 1 plus b into minus 1 plus 1. Therefore, 1 is equal to minus 2a plus b into 0. Therefore, a is equal to minus 1 by 2. Now, we got the values of a and b. So, substitute in above equation. So, we get 1 upon x square minus 1 is equal to a upon x plus 1 plus b upon x minus 1. A is minus half upon x plus 1 plus b is plus half upon x minus 1. So, here we write minus 1 by 2, 1 upon x plus 1 plus half into 1 upon x minus 1. This is the solution, or you can take half as common. So, we get minus 1 upon x plus 1 plus 1 upon x minus 1. Okay. Next example. F of x is equal to x plus 4 upon x square plus x. Again, resolve the partial fraction. So, f of x is equal to x plus 4 upon x square plus x. In denominator, take x common. So, we get x into x plus 1. Again, we got two distinct factors. This is one factor and this is second factor. So, we write x plus 1 upon x square plus x. Sorry, here we write x plus 4 upon x square plus x is equal to a upon first factor, that is x, plus b upon second factor, that is x plus 1. Cross multiply. So, a into x plus 1 plus b into x upon x into x plus 1. Now, equate the numerator. So, x plus 4 is equal to a into x plus 1 plus b into x. Consider equation number star. Now, put x is equal to 0 in equation star. So, we get 4 is equal to a into 1 plus b into 0. So, a is equal to 4. Now, what we put? X is equal to minus 1. So, put x is equal to minus 1 in equation star. We get minus 1 plus 4 is equal to a into minus 1 plus 1 plus b into minus 1. So, here b is equal to a into 0 minus b. Therefore, B is equal to minus 3. Therefore, x plus 4 upon x square plus x is equal to here a upon x plus b upon x plus 1. Substitute the values of a and b over here. So we get 4 upon x plus here minus 3 upon x plus 1, which is nothing but 4 upon x minus 3 upon x plus 1. Next example, we solve the partial fraction x square plus 4x plus 1 upon x minus 1 into x plus 1 into x plus 2. So let f of x is equal to x square plus 4x plus 1 upon x minus 1 into x plus 1 into x plus 2. Here, three distinct factors in denominator. So we get x square plus 4x plus 1 upon x minus 1 into x plus 1 into x plus 3 is equal to a upon first factor plus b upon second factor plus c upon third factor. Now cross multiply. So a into, here we want the denominator x minus 1 into x plus 1 into x plus 2. So here a into x plus 1 into x plus 2 plus b into x minus 1 into x plus 2 plus c into x minus 1 into x plus 1. Now equate the numerator. So x square plus 4x plus 1 is equal to a into x plus 1 into x plus 3 plus b into x minus 1 into x plus 3 plus c into x minus 1 into x plus 1. Consider this equation as start. Here we have three distinct factors. So we put, here write the three in bracket. So first we put x is equal to 1. Why? Since x minus 1 is equal to 0, so x is equal to 1. Second, we put x is equal to minus 1. Since x plus 1 is equal to 0, so we get x is equal to minus 1. And third, put x is equal to minus 3. Why? Because x plus 3 is equal to 0, so x is equal to minus 3. Okay. So put one by one in equation start. So first put x is equal to 1 in equation start. So what we get? Here 1 square plus 4 into 1 plus 1 is equal to a into 1 plus 1 into 1 plus 3 plus here b x minus 1, so 1 minus 1 into 1 plus 3 plus c into 1 minus 1 into 1 plus 1. So here we get 1 plus 4 plus 1 is equal to a into 2 into 4 plus here b into 0 plus c into 0. So here we get 6 is equal to 8a. Therefore, a is equal to 6 upon 8. So a is equal to 3 upon 4. Okay. Now put x is equal to minus 1. X is equal to minus 1 in equation start. So we get here minus 1 square plus 4 into minus 1 plus 1 is equal to a into minus 1 plus 1. So here we get a into 0 plus b into minus 1 into minus 1 plus 3 plus c into 0. So we get here 1 minus 4 plus 1 is equal to b into minus 2 into 2. So here minus 3 plus 1 minus 2 is equal to minus 4b. Therefore, b is equal to half. Now, put x is equal to minus 3 in equation star. So we get minus 3 square plus 4 into minus 3 plus 1 is equal to a into minus 3 if we put. So a into 0 plus b into 0 plus c into minus 3 minus 1 into minus 3 plus 1. So minus 3 square is 9, here minus 12 plus 1 is equal to c into minus 4 into minus 2. So here minus 3 plus 1 minus 2 is equal to 8c. Therefore, c is equal to minus 1 by 4. Therefore, our function x square plus 4x plus 1 upon x minus 1 into x plus 1 into x plus 3 is equal to a upon x minus 1 plus b upon x plus 1 plus c upon x plus 3. Substitute the value. So a is 3 by 4. 3 by 4 upon x minus 1 plus b is half. So half upon x plus 1 plus c is minus 1 by 4 upon x plus 3. So here we get a upon x minus 1. So 3 by 4 upon x minus 1 plus b is half. So half upon x plus 1 and c is minus 1 by 4 upon x plus 3. So write this way, 3 by 4 into 1 upon x minus 1 plus half into 1 upon x plus 1 minus 1 by 4 into 1 upon x plus 2. This is our solution, or you can take 1 by 4 as common. So we get here 3 upon x minus 1 plus 2 upon x plus 1 minus 1 upon x plus 2. Okay.